I'm assuming everyone can.
Yeah, it looks real good.
Okay, cool. All right, so let's get started. So welcome to another lesson. This is going to be on functional programming. So this is going to be well, I know on the spreadsheet it says like part two OOP and functional programming, but yeah, I kind of really split them into two very different topics. So yeah, so oh, here we go. Here's our uh, Telus principles. We all know that, and I'm just gonna skip that. So today, gonna do some speaker introduction as usual, and then gonna jump into these high-level topics on functional programming. So the first really important thing to know for us, well, I would say personally for me, I had a really tough time really understand what exactly functional programming is, just because like I don't know if any of you have tried to Google what is functional programming uh, versus like object-oriented programming versus imperative programming, declarative programming. I've always kind of had a lot of questions about what that is, so I'm gonna try to just uh, take. I'm gonna try to put my take on how to answer that question. And then we're going to jump into some topics. The first one, into functional programming. The first one is looking at loops and then how we can, replace loops with, in this case, recursion. So using just functions. And then we're going to look at kind of the higher order functions. So, uh, most people, when they think of functional programming, they just think of like, the, map reduce and filter. So for us, that is part of what functional programming is, but we're gonna just look a little bit deeper as to how these things are implemented, and then kind of clear up some terminology about words like in JavaScript. There's first class functions, or there's yeah, first, what is a first class function? What is higher order function exactly? Just I'm going to try to clear that up. And then we're going to talk about currying. Not sure if people have heard about this word, but I remember hearing about this word. I didn't really know what that was exactly. Right? I mean, I thought had something to do with food, but it didn't. So yeah, I'm gonna try to clear that up as well, and then probably the most fun part, which is the composition and piping part, which is kind of what functional programming is all about. Well, not necessarily, but very something that you guys probably have seen every day when building, React applications. We use like pipes, or sorry, we use what was that library at Telus where we use compose on uh, sorry, on the like, what do you call it, when you use compose on the React components, right? So yeah, so that's general summary, and then yeah, so once again, I'm Yichen. I'm a developer at Kudo, and introduce yourself, Cody.
Hey, yeah, I've actually taught one of the JDP sessions, but just a developer for SHS team right now.
Yeah,
I've been with
cool.
Telus for about 9 months.
Oh, that's cool. Yeah. Okay. So where is the? By the way, what does SHS stand for? I just kind of copy pasted.
Smart Home Security.
Okay, got it. Got it. Okay. Okay. So the first, like I said before, like what is the first thing that we're going to try to demystify is what is functional programming. So functional programming, I would say there's no strict definition, but I remember when I was a long time ago, even now, I mean, I would always hear things like, those functional programming conferences you would almost always see like a lambda sign, and then you would hear all these people, talk about things like, oh, pure functions. Oh, this function is impure. Ooh, this immutability and monads, and oh, higher order functions, right? Like I would hear all these words, and for me, I never really understood any of that. Now I do. I know what those things are, at least from a high level. We're not gonna go over like the super deep topics, like specifically monads and functors. Although by the end of this 2-hour introduction, you should have enough basics and fundamental understanding to basically go and explore those types of topics. Yeah, I don't cover immutability as well. I'm sure most of you guys have an idea of what that is, but specifically, I don't think I was going to have enough time to cover that. But I am going to cover things like higher order functions, pure functions, side effects, and a bunch of other stuff that are more about just understanding the ground level stuff, so that you can actually go and explore some of the more complicated topics, and perhaps even learn a language like Haskell or Scheme or something like that, which I have. I don't know if I mentioned, but I actually have programmed in them mainly in school when I was taking a functional programming course. So first, imperative versus declarative. I heard this a lot before, and I still hear this a lot now. And essentially, to really understand, to really give a general overview of what functional programming is, it really is more just the style of programming. So essentially, the way I like to think about it is it just has to do with mainly how data is being flown or manipulated. Okay. So in the imperative sense, when a lot of people say, oh, this piece of code is so imperative, so from what I've experienced, it just kind of means, imperative means, okay, do this, do that, and do that, and that's how it is. And declarative is more of, well, I want this, so can you give me this, right? So that's kind of the difference between imperative and declarative. But for things like object-oriented programming, it's actually mainly imperative, but it can also have characteristics of being a declarative style. Like for example, you'll hear like Java, like or C#, it's an object-oriented language. That doesn't mean it's 100% imperative with no declarative declarative features to it, right? It's the same thing with when you say functional. Yes, functional is very declarative, right? Meaning that things that you guys probably have already seen, especially like the higher order functions, right? Like map, reduce, filter. Those are very declarative because there's a very high level abstraction that's happening where you put some data in and then the data kind of flows out magically in a way, right? And essentially that's generally what the difference between the two are. And object-oriented is essentially just kind of a type of imperative style, and a functional programming is a type of a declarative style, right? And again, they're not mutually exclusive. They can cross with each other, meaning, like I said, in object-oriented programming, it could be both imperative and declarative, right? So yeah, there we go. So here's probably should have showed this slide earlier, but to kind of look at the more characteristics of each, object-oriented programming deals more with objects are self-modifying data structures that you use embedded pieces of code to handle most operations. Objects are created using classes, which act like templates, right, for how each piece of data will behave. There's a way to describe those instances created from classes with attributes and behaviors, right? And functional programming, data and code are completely separate. Yep, and they are in an ideal situation. Okay, functions receive data, transform it, and return it. Additionally, functions can receive other functions as arguments and return other functions. Describe a machine that receives and transforms different pieces of information. Essentially, what it just means is in object-oriented programming, you would create sort of these different, classes, right? And you would create instances from those classes, and those classes have properties in them. And you can use things like dependency injection, right, which is basically passing, objects into other methods or objects and constructors or their methods, and then those objects could communicate or interact with other objects, and those methods, right, those properties created are very explicit. Whereas for functional programming, it's more of the, okay, how that data is being manipulated in object-oriented manner is through the behavior of all these different types of classes and objects that are explicit to each other, whereas functional programming is more of like, I'm going to try to create a function that can, be reused, a million times, and we can, kind of imagine a factory and a conveyor belt, and this information literally just goes through this entire factory and it comes out. So it goes in here, it comes out the other, and it gets transformed, right? Again, those two are very, like, one can have characteristics of the other, right? And this is not a black and white thing, okay? So functional programming, more of a style, okay, with certain different techniques that you can use to produce the same results if you just did it, and versus, say, an object-oriented programming, right? And so a good example of that is like a loop, right? So a loop is thought as more of an imperative style because you're literally, going through and keeping track of a variable, right? Most of the time you're keeping track of a variable, right? An incrementer, and then you're kind of just literally going through it one by one, and you're keeping track of the state. And then, whereas in a functional perspective, you're not using a loop, but rather you're using the same function over and over again to try to kind of manipulate and pass through the data. And so those are, again, different types of styles. So now we're going to move on to me introducing you the difference between what's called a pure function and an impure, not pure function. And I'll explain later why I guess this is very important. So essentially, from the diagram, right? I'll explain the diagram. So essentially, the diagram I kind of put here is so our black box, right, which is kind of our function, right? And if you guys didn't know already, functional programming, you kind of have to use function, but it's not all just about function. In JavaScript, it just so happens we have the function keyword, and we have a bunch of other nice built-in features and characteristics that we have, such as closure, that allows us to program in a more functional style. So in this case, the black box is, it's a function, and just like in math, if you guys, I'm pretty sure most of you guys have taken a math course, the function is the black box, and then you have some sort of input, and then you just put that input in, and you get that output out. In this case, there's a green circle, and the output is a purple triangle. So a pure function essentially is something ideally that looks like this. And whenever it becomes impure is when there is something that is going on that the function is creating some sort of side effect, right? So essentially, let's say we have the same function, it does the exact same thing, but then inside here we sort of just change something, but it was able to modify something outside the scope of this function itself. That would be considered an impure function. And so essentially, this picture right here of what I'm trying to illustrate is a pure function cannot have any sort of what we call side effects, right? Which is basically you should only have an input or multiple inputs. That's fine too, where the input goes in and then there's one output that comes out. If there's any side effects, right, within a function, then that function is not considered pure. So let's look at some. So I forgot about this. So I put some rules, or I guess I don't know, characteristics, right? Where just kind of repeating what I said, except putting it in bullet form to help us remember, because this is going to be important. So a pure function, is essentially a function that only takes in inputs or input, and it returns an output. So it has no side effects. So once you call the function, the outside world is not affected in any sort of way. And it has to be consistent because the same input must yield the same output. The same inputs, must output the same output every single time, right? Or else it's not consistent. It's not a pure function. So what I just said about the inputs, though, like there's some I guess notes that I would like to add. So if a function does not take any input, okay, and or return any output, generally speaking, it's most likely an impure function, okay? And the reason why is because it's not even about that. It's more of why would you have a function that takes in no input? Because if you think about it, you know, if you have a function that takes no input, you're probably just wrapping some procedural code inside a function, right? It could be probably like a initialization for configuration, right? I've seen that a lot, which means that, you know, your function doesn't need to actually have any output, and it'll just create some sort of side effect, right? Maybe change a, you know, global variable, and I'll show you guys in a sec, right? And it's very suspect, right? When you see a function that takes no input, because it's kind of like, well, what is this function used for? Why do we need the function in the first place, right? And if it doesn't return anything, it's not considered well, it is not considered an impure function, but it's more of like, why would you have a function that doesn't return anything? That, you know, that kind of is a clue that, okay, this is not this is not a pure function. Okay, so we're gonna go through some code examples, okay? And essentially, I have some examples here. Is this big enough, by the way, if I make it this big?
Can you make it a little bit bigger, please, Chen, on my small screen? Thanks.
Oh, yeah. Okay. This is good, right?
Yeah, it's pretty good.
Okay, so like I said, we want to understand what is a pure function and what is not a pure function. So here's an example of what, very, very simple example, that is a pure function. So the function I have is called greet. And remember, it takes an input, all right? And then we return an output, okay? And it's consistent as well, because we put, you know, if we put the same input, we're gonna always get the same output, right? So this is definitely a pure function, okay? For an impure function, right? Here's a very good example. First of all, it takes no input. Okay, well, again, not saying that, you know, just by looking at it, well, this is, you know, this is not a good function, or you shouldn't be writing a function like this. That's not the point. It's more of, yeah, you don't have an input, and not only that, you don't have a return statement, which means you don't have an output. And I'm not going to count when you do when you don't do a return explicitly in JavaScript, you technically are returning an undefined, which is a known primitive in JavaScript. But again, that's more of a JavaScript thing. Generally speaking, you should have a return. In this case, we don't have a return, so it's pretty obvious this is impure. And not only that, we have a console log. So regardless of what you see here, console logs are actually something that makes the function impure. And you could make the argument, you could say, well, I'm technically not breaking the program, but, you know, because I'm technically just, you know, logging something to standard out. Well, I mean, that is, in a way, that is affecting the outside world, even if it means no harm or it doesn't change anything, right? So there's a side effect. And then the fourth reason is, well, this is going to be pretty obvious if you just look at the code, which is, if you look at it, when I call the same function twice, so the first time I call this function, you know, I get hello Alonso, and then I did something to this function, right? So imagine there's like a million lines of code right here, there's just a bunch of random code here, and then like on line 10,000, I call greet again. I'm like, okay, I should be expecting hello Alonso, right? And then we're like, no, it's somewhere in there in the middle. This global variable name was assigned Alan, and then I find hello Alan. I'm like, whoa, what's going on here? Well, there we go. 4 reasons why this function is impure, right? So now I want everybody, since I know I went over everything quite quickly, but can anybody tell me whether or not this function here is pure or impure? Anyone? And why?
Well, it's always going to return a different number.
Okay, there we go. I don't know who said that, but yeah, there we go. What about this one? Add. What about this one? Is it a pure or an impure function? Anyone?
I'd guess this one is pure since it takes an input and returns an output.
Yeah, and are we always going to get the consistent output? Like if I put in 10 and 15 and, am I going to get something different?
Shouldn't.
Yeah, okay. Yeah, you're right. So this is pure. And then what about this one? What about this one?
Well, that would be an impure one, I guess.
Yeah, it's an impure. Yeah, and this is pretty I don't know if people still do it, but like people will, like, maybe not in the config, but I've seen this a lot, like in other places where people would just do this, and I think that's fine. But it's definitely not pure. And of course, like whoever that does this in their code, right? I do it too, depending on what code it is. It's not about making a function pure or impure. It's just we're just trying to understand what these are. So why do we need to know the difference between pure and impure function, and how does that really relate to functional programming? Well, one characteristic of a pure function is that it's deterministic, and this is a very important thing because, as you know, like when we put in the same input, it's always going to give us the same output, right? So basically, not this, right? And this is good because it's very predictable, and it could allow us to do other things like composing the function and piping through the function, which we'll see later, right? And that's kind of the whatever I said about the conveyor belt. Each of these little parts of a conveyor belt has to do that one thing and one thing correct, right? Because each of those one thing on the conveyor belt must take whatever the object comes in and then always produce the same output given the same input. And that's kind of the idea here, right? So now let's jump. So now that we have a very good idea of what is side effects, pure functions, impure functions, let's jump to kind of the first topic, or not topic, the second coding part. So essentially, like I said before, loops, they're very imperative, recursion, very declarative, and simply because I put some characteristics here. It's stateful, right? One is stateful. You always keep. We're gonna use the old school loop, right? Like or the while loop, right? You always like for the while loop, you want to put a value outside. Let I equal 0 or count equals 0, and then you have a conditional, and it's like, okay, well, when the I is equal to this, jump out of this loop, right? Whatever it is. And so for in order to do it in a functional style, well, first you need to use functions, right? But it's more of a self-referential thing that it does not care that much about state, and it's because it is able to. So basically, for a recursive, like recursion makes it very declarative because we're not really keeping track of state, and we're using functions, of course, and we're referencing itself, or we're referencing the data ourselves inside. And for something like this, JavaScript is perfect because we have something called closures, and it helps us a lot. And so what I want us to do is I want us to basically try to convert. Well, I want to basically show a couple of rules, right? Because I'm not sure if it was like Carmen or someone who asked 2 lessons ago about like what's a good way to keep track of, like, to come up with a recursive algorithm. Well, I kind of wrote down my own rules, right? And of course, there's no shortcut to I guess getting good at recursion. It is just about practice, but this is but there are other languages such as off the top of my head, Haskell and Scheme, that don't have loops, right? And they're considered like very, very pure functional programming languages. And it's a good way to kind of see how you can kind of use a couple of patterns to really loop through mainly arrays, right? Strings as well, that could work, right? And so here's kind of the rules that I made up for basically converting some sort of array that we have to recurse over. And this is usually almost always true, right? So the first thing that we can do, if we were to convert a function that is trying to loop through an array, is that we have to think of a base case. And it just so happens that because we know we're working with arrays, most of the time the rule of thumb is we want the base case to be something like if the array reaches a length of 0, or or the count of the certain array, like the current array right now is at its smallest form, then we do a return statement, right? We jump out of the loop, right? So you'll see that we'll see examples of how this is done in a couple minutes. So the recursive step, right? This is kind of the tricky part, but I think there's a very easy kind of pattern that we can see. So essentially, we always get the head, and then we get the rest of it, which is the tail, right? So we always get like the first element of the array, then we get the rest of the tail, and then we pass that tail as a parameter into the function recursively. And we'll see this with the two examples I have right now. One is a very easy one, another is pretty easy as well. So the first one is, you kind of see this all the time, right? You have a function, and then there's, you're going to see that like array, right? In this case, it's a number being looped over. And we do some operation here. In this case, we are console logging the thing out just to show us how it's working. So if I run this, I'm going to get 10, 60, 10, 55, 46, right? In this order. And it should be no problem. So if we want to basically convert this into more functional style, more recursive style, we can follow these steps, and we can do this. So what I did here was I'm going to go through the recursive step here, and then I'll talk about the base step. So the base case. So like I said, we get the first element, okay, and then we do something. So in this case, we're just we're doing whatever, we're console logging it out. And then we get the tail, which is basically, in this case, numbers that slice on the first index all the way to the last. We just take the rest of the elements, right? And then we pass the rest of the elements into the same function. And so as you can see, our recursive step is making the numbers array smaller, right? And so eventually we're going to get to a length of 0, and eventually we're going to reach a base case that is going to add. So in this case, we're not doing anything because we're not keeping track of a number. We're not doing a return on this, right? We could just jump out of this function like this, right? And this is essentially kind of the core patterns. Like if you see any of the other, especially languages that don't have loops, this is essentially like their bread and butter of going through and recursing through, like iterating with recursion through a list, right? Or a long collection of objects. This is basically the pattern, right? And you can actually apply this pattern, this recursive pattern, to almost any problem that has to do with like I said, strings and lists, like arrays in this case, right? Yeah, so let's go through a different example. So here I have this function called sum. So I'm sure most of you guys know exactly what this function is going to do without even looking at it. And so I just, it's the same parameters, right? Just a list of numbers, and then we go through a for loop, just like you would probably do, like most people would do this. And then we get the sum, and it's going to be 10. So how do we apply sort of the same pattern and make this more, functional-esque, right? We use the same rules. Okay, so we're gonna first let's look at the recursive step, right? Which is probably the most mechanical one, which is here. We're gonna take the head, okay, which is the first one, and then we're going to take the tail, and then we're going to then call our function and then add that tail into that function. And in this case, we have an operation right here, which is basically doing a return, right? So obviously I wrote a short form because I didn't want to, be very explicit here, like I was here. But here, this is essentially our recursive step, and then our base step. Again, it's something to do with the length of the array, right? Because we're just basically shrinking it. And so numbers.length equals to 1. I return, okay, numbers, like the first index of numbers. So in this case, you could have, I think you could have done something like this as well, because as long as you jump out of the loop, right, then it should be good. So in this case, if I reach 0, then, well, there's nothing left, and the sum that is being added up, I'll just add 0 to it. Doesn't really matter, right? So this would be an example, a little bit more complicated than something like this, of using recursion to convert basically a loop. And what most people would do with a loop would just kind of follow this little template here to recurse through something in a recursive fashion rather than just a loop. So that is, let me see if that is it with the, okay. Yeah, so I think this should be pretty simple. Again, with recursion, it's more about practice and seeing a lot of different problems rather than me just giving you this template. I think this should help a lot of people when it comes to something like this, because this is a nice framework. I wish somebody would have just told me here's some mechanical steps, and then you can, like, I don't know, go on LeetCode and do some questions, and then you'll really see how like having some of these ground rules will really help you. Okay, so the second, oh yeah, yeah, Carmen. So yeah, just remember this pattern. All right, Carmen. All right, so next one. So we're gonna kind of apply this pattern to something else now. So the next topic is going to be higher order first class functions and higher order functions. So like I said before, the main thing that I remember having trouble with was kind of understanding, especially in JavaScript, because JavaScript is it has functional, like if you ask me pre-ES6, I would say it's very, very much a functional programming language. But ever since they added classes, it's kind of like they're making things much more confusing. I'm like, wait, so there's a prototypal, there's this prototypal model with JavaScript, but they added some syntactic sugar with this class keyword, and then we have all these like other things like static and super and classes. And now I don't know if JavaScript is considered quote unquote functional or I definitely don't think it's object oriented in the traditional sense. But yeah, like I think right now, I think a big part of JavaScript is sort of not knowing a lot of these terminologies. And I think one of those big terminologies was first class functions, because I'm like, what does it mean, first class functions? What does that mean, right? Especially post ES6, because now we got the class keyword. So it's essentially just this: functions. First class functions are just functions that can be passed around as values. That's it. Okay. And then we'll see what that means. And the higher order functions are just functions that can use first class functions, right? So let's look at what that actually means here. So here, to clarify, we have an array. Okay, so we create an array, 5, 10, 15, whatever. We do a map. And then we call this function double. So this essentially just takes each number in the array, and it just doubles the numbers, so you get like 10, 20, 30, right? And so in this case, to really clarify, so first class functions, in this case, double, okay, is the first class function, because the function double is the one that actually returns some sort of value, right? And then higher order functions is essentially the dot map, right? So a confusing part is, and again, I hope you were paying attention last time when we were looking at the prototype chain and how in the heck did we actually get from an array, because from an array to have the method dot map, right? Because this could have easily been a helper function called map, right? And this could have easily been a helper function called map, and then this is going to be implementation detail, and then this could have been easily a function, right? Right here, right? But it is on the prototype chain, right? Which is the array.prototype.map, right? So I think this is something else that confuses other people if they haven't really come from the JavaScript world. But yeah, the map itself is the higher order function, because it literally takes another function, and which is basically in this case a first class function, and then uses that function. And you can also relate, because in JavaScript we use callbacks all the time, and those callback functions are essentially first class functions, right? So there we go. So now let's actually implement one of those three really popular functions, which is reduce in this case. So for reduce, just to remind everybody what reduce is. So reduce is a higher order function. Okay, it's a function that can take other functions as arguments, and one of those functions is the reducer function, right? And I wrote a little definition here, which is basically takes two arguments, accumulator, and then what was it? Accumulator and the value, right, of the. So there's an accumulator, and then there's another value that's coming next in the array, okay? And essentially, the return of reduce is not going to be an array, unlike map and filter, but rather it's just going to be some sort of a single value. I mean, I guess it could be an array, technically speaking, if you wanted to, right? So an initial, let's see, what is this? An initial value, right? So that, again, that could be initial value of an array, could even be an object, most likely it's going to be an integer, right, or a string. And then what was the third parameter? Oh, is the array itself, right? So this is kind of the contract that we need to create this function. And so I did it very simply in a iterative fashion. Okay, so fun fact, I actually got this. I remember this one time as an interview question, and I don't know why. It took me a really long time to kind of figure it out, because I don't know. I think I was really torn between using like the iterative way, and then because I was going through like a recursive way, because I felt like it was going to be easier, but in the end it took me quite a long time. I was able to get it, but I actually used an iterative way. Not sure if that affected whether or not the person thought of better or worse than me, but it did take me a while. So yeah, that was a very interesting, just personal experience. Anyway, so for the iterative method, I'm just using the for of loop, because array is going to be an iterator, because it has the add iterator symbol, so we can use the of keyword. And essentially, it's very simple. I'm just passing in the initial value, and then I'm going to apply the function with that value and the element in it as well. And then I'm assigning the init here, and then returning it at the very end. And so to really test whether this implementation works, we'll just use this nice little piece of code right here, right? So as you know, this is essentially the equivalent as just summing up the initial value. So the initial value is 0, right? And then we're just adding it up through this function right here that's being called right here. And I guess maybe I'll just run it as well, just for the heck of it. So here, I don't know if I have anything on the bottom of this page. Oh, there we go. Okay, so I don't think I ran this yet, so hopefully it does work. Okay, so it does work. I'm getting 15. I'd be getting 15. Yeah, I think that's correct. Yeah, that's 15. We start at 0, right? So now we want to try to, again, like do this without, what do you call it? Without using a loop. And it's going to be with the same pattern that we had previously, right? Which is this thing, right, that I made up. So in this case, I'm going to show you guys what I did here. And essentially, it's going to look very, 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 very similar, right? So again, the reduce function, and then the same parameters. And I have some helpers right here just to make my life a little easier, to make this a little bit more readable. Essentially, I'm doing this check, and I'm saying, okay, remember the base case, right? Remember the base case right here? Okay. Usually when it gets to the length of 0, we do something. Well, in this case, we know what we're returning. We're returning the initial value, right? Because that is the definition of the reducer function itself. It's trying to get that that initial value, and then whether it be a string or a number, we know it's going to return that, right? And so again, here I'm doing pretty much the same thing as I would following the template, except so here I do a head. So I get the first where is that? I get the first element, but in this case I have to use some sort of operation on it, right? So remember here I did a console log, right? I did a console log. So I performed some sort of action, right? In this case, it's performing a function, like the passed in function fn, and then putting that in there, and then and then assigning it this value, right? And then the tail, right, which is basically I'm going to take everything after the head, right, except the head. Everything after the head, I'm going to pass the tail into this function recursively, and this is a very more obvious thing now, because reducer function is never going to change, right? The initial the tail is always going to be here. The trick, that might have been a little bit more complicated was, okay, we gotta figure out how to pass the initial value in here, which in this case I think it's kind of obvious, just because we know that this function itself will return the same type as the initial value, right? So that's why that's a little clue. So anyway, this is basically how reduce is actually implemented. Not exactly, but this is essentially the gist of how reduce is implemented in the array.prototype.reduce, right? And if we do a little, I think this is the same code. Yeah, it's the same code, except it's not reduce 1 anymore. It's just reduce. I'm going to get the same. Hopefully, I'm going to get the same answer, which is 15. Yeah, there we go. So there you go. So yeah, how cool is that, right? Applying kind of this nice little neat pattern, and then applying it not only in what do you call it? Basically applying it in a function that we pretty much already use, right? And kind of going lower level and seeing how people actually do that. And you can do this for map and filter and whatever else is there as well, right? As you can probably do that as a little exercise by yourself. I see a question. Where is the reduce fn? So that's the function that we pass in, right? I think I got the order a little bit. I think here, actually, yeah, no, that's essentially it. So this one is this one right here, right? As you can see, that's how we were able to, that's how we were able to sum everything up, right? Because this is the one we passed in. Okay, so let's see. So moving on to the next topic, which is querying. So again, another concept. I feel like just if people haven't been in the JavaScript community for a long time, like it's just one of those things that people might have heard of, but they don't really know too much. And I'm gonna give a really simple kind of brief overview on how it works, right, and the practical application of it. So the first thing is that it really has a lot to do with closure. So just a little bit of a review of closure. So if you guys recall, I think it was like the first lesson I did on lexical or on scopes and closures. I quoted Kyle Simpson, where he said a closure is when a function remembers its lexical scope, even when the function is executed outside of that lexical scope. So to review what that really means is that if you recall, lexical scope just means there's a phase in the program where there's lexing, and this lexing pretty much defines all the scope before the program is ran, because JavaScript is a build first and then run after a program. And so that lexing part, it's actually already putting all the scopes into different places, okay, before it actually runs. So what happens is when it says when a function remembers its lexical scope, it just means that everything is already put, the scope is already put, the variable is already put, in the global, parent, and some sort of nested scope, right? Yes, Dan?
Yeah, Chen, is this how like our functional React components, like when we export them, they remember all the imports that you've brought into that module because of they're all part of a closure?
Oh, I don't know about that module part. Like are you saying when you import a component, you can use that component? Is that what you're saying?
Yeah. So I guess like a React component is a function, and they exist in a scope, but then when you bring them into, like if you bring it into a new component, I guess it remembers all of the scope that you declared it at, including like all the stuff that's part of it, right? Like all the inputs and things like that, even if they're outside scope of the parent component.
Okay, so here's the thing with your question. I don't know if you thought about it, but when you do an import, like on modules, I don't know if you recall what I talked about for modules. They're in their own little scope. Do you get what I mean? So that's why.
Yes. Okay. Right. Gotcha. So.
Yes, and then I don't know if you recall, like 3 or 4 lessons ago, I had a little trouble. Like basically, when I declared a global variable in a different module, right? I was able to access that global variable. So that's the only way to access that variable through different modules. Other than that, there's no other way to access those particular variables because they're binded to that particular module. If you recall.
Yep. Okay. Right. Gotcha. So not a closure then.
Yeah. No, because it's a module, right? They're enclosed in their own little thing.
Okay.
Yeah.
Cool. Thank you.
Okay. Yeah. Anyway. So again, what was I gonna say? Oh yeah. So lexical scope essentially is just my function has access to the scope within itself, right? In the parent and the grandparent, whatever goes up the chain, and all the way to the global scope, right? Unfortunately, it doesn't have access to other modules unless those other modules declared a global variable, right? Which is again that which is basically what I was trying to explain to Dan, right? So that's the lexical scope part. But what does it mean? Even when the function is executed outside of that lexical scope, it just means that if you recall, I think I put an example where I did something like, I had a function, right? And then I invoked it, and inside the function, I had another. So I have a function, okay? I have a function, right? So I have a function parent, okay? And then I have another, let's say I have, name. And then I have a set timeout. And if you recall, I said that this, okay, let's say, I don't know, 10 seconds. I'll just write name right here. So the reason why, so again, if I was to explain to somebody, okay, this is how functions work, this is how, you pass this thing, like you're supposed to pass this parameter in, and then in here, you're gonna have access to the variable name, right? But then I said, okay, by the way, I have this thing called the set timeout, and set timeout lets me perform this function, right? This particular function here, which has access, which I want to access. Okay, I don't know what I'm doing here. I should have done that. Yeah, which lets me access name from here. So it's actually not an obvious thing, because some people would think, well, if this function is being executed like 10 seconds into the future, the program's already done running. How the heck is it possible that this function here is able to access the name, which is in this, right? Which is here, because technically speaking, this function is already done, right? So I don't know if you guys recall, but I said something like the preservation of linkage between the variables from here to here is what it means when I say even when the function is executed outside of that lexical scope, because it is being executed outside of that lexical scope. But there is a preservation of linkage, okay, that it knows that in the lexing phase, all these variables have already been linked together, and that no matter what happens here, this function will still have access to those other variables, and whether those variables change or not, it will be linked here. Okay, so that is a review of what closure is. Now, moving on to currying? What is currying? Essentially, currying is basically making use of this closure functionality that we have in JavaScript, and it tries to break down a multi-argument function into a series of smaller single-argumented functions, right? So here's an example. So let's say we have and I have some other examples I'll show you guys later, but this is the one that I came up with, which is add prefix. So as you can see, when you have the function add prefix, right, I am doing a return function on another word. So as you can see, this is essentially closure, right? Because look, I have another function here, and somehow it's able to access this variable here, right? This is the closure part. This is the thing that helps us. So what happens here is I want to just create this one function called add super prefix, okay? So I'm gonna put the first parameter super here into this function, and I'm going to assign it as a value to here, okay? And so this const add super prefix is now reusable. I can reuse this anywhere. And so I'm like, you know what? I know that there's another single parameter that comes after that is word, right? And I'm gonna go, okay, add super prefix, aggressive, fun, cool. And then when we do a console log, we're able to do something like this. And this is essentially currying, okay? Which is basically, like I said, breaking a multi-argumented function into a series of single argument ones, right? And what do I mean by multi-argumented function? Well, here is an example. When we have something like greet, right? This is 2 parameters, right? So, you're like, well, this isn't really reusable as this, right? Like what if I can make it so that it's something close to this, where I can just do an assignment, right, and take advantage of closures in JavaScript, and then say, something like greet, and then I do like greet with hello, and then I can use that hello, and then I can use greet. I can use that thing to chain it with the next parameter, which is name. And essentially, this is the example I'm going to get to, which is this, right? This is essentially a lot more reusable than something like this, right? Because I can assign something like this to a variable and reuse that. And so here it is, right? So greet, I don't know, greet at Italy. Okay, I don't know what this is. Greet initial. So the first greeting is, I think I was right. Something like greet English. Yeah. So greet English, right? I basically call this. I pass in hello, and then I'm able to call this function and then pass in another argument, right? So we essentially broke down two arguments into just single arguments. And you can see there's various advantages, right? Because we can potentially add even more nested functions here, right? We can say greet, I don't know. So greet, and then the function, like we can do something like this. Greet, and then we can add another variable, right? And then something like that, right? And then, oh crap. Yeah, you guys get the point, right? And then instead of this, we can now do something like this. Something like this, right? Or we can, we can do it like this, right? I'm gonna undo all this because I actually want to run the original code, right? And then we can make this much more reusable, right? So again, this is just one of those. This is essentially currying, and it's essentially taking advantage of closures, right? Which is built into JavaScript. I can do this. So here, it's the same thing, right? I'm just saying greet Texas, and then I go curry greet howdy, and then it makes use of this function. And like I said, you can try to add as many of these as you want, right? So, and hang on, let me just see if I can. Let's just run all this and see. So here, there we go. So we have super. You see the code right here, super aggressive, super fun, super cool, right? And then we're going to comment this out, and then we can do console. It should give us, since I ran this before, it should give us whatever it is that's in the comments that I've written, right? And so there's a lot of usability with this, and we're gonna just run this first. Yep, so there we go, right? Exactly what it is here. So, so this is, hopefully, if you're like me, I didn't really know what the word curry means. Now you know what it means. All right, so yeah, so the next topic is going to be probably the most interesting one. So I just took this slide literally from last year's, from Fabio's some slide. And essentially, this is where there's this concept of composition and piping, okay? And this is very, very applicable because, as you can see, Redux uses this thing called combined reducers, right? Which takes a list of functions like that. And so, again, I'm going to go through like more lower level, like not lower level, but more raw examples. And so I'm going to explain what composition is. So composition is essentially just, when you guys all took math, right? You have f of x, and then you have g of x, right? And then there was some problem where it's like, oh, now you have f of g of x, right? And that's, I believe, called a composite function. That's essentially what composition is essentially. It's essentially just taking a function as an argument, and then you kind of here you have f1, f3, f2, and f3. And what happens here is, guys, remember bedmass, right? You look at the brackets, and in this case, you look at the most inner brackets first to get the values first. So f3 would be calculated first, and then f2, and then f1. So that's essentially what composition is. Okay. So what's pipeline, or what's piping? Well, I'm sure most of you guys use Linux or Unix, right? You guys know what a pipe is. It's a straight line, right? And essentially, when you do something like ls, and then you do like a pipe grep, right? And then you do like so grep, and then you try to filter it down, and then you do a grep. Sorry, not a grep, a pipe, and then you do like a cut, or you do you can use awk, right, or something like that. You can just pipe through the data and try to filter it down little by little. That's essentially what pipe is, and it goes from left to right because you have one data that's flowing. So from this side, and then you flow it to that side, and you pipe it to that side and that side, and at the end it comes out, kind of like in that conveyor belt factory, right, where you go through this, and then this, and this, and this, and then at the very end, you come out with a completely new product, right, or a completely new output. So that's essentially what. Yeah, exactly. So Ryan, only pipe I use in Ramda library. Yeah, exactly. Ramda, that's a good library, right? I was going to actually show the library, but then I'm like, what's the point of me doing that? Like, you could just read the docs, right? We want to go a little bit more understanding the core concept itself. Okay, so now we're going to go through some code. So the idea here is we want to understand. So we want to kind of apply what we've learned, right, in the last hour or so, a little bit more than an hour. And the first thing, so we're gonna go through this example, okay? So we have 3 functions here, and what I want to do is I want to figure out a way to basically, for example, in this case, use some sort of piping mechanism to say, okay, here's an initial value, right, which is 4, and I want to do something like increment by 1, and then I want to triple it, and then I want to take away 2, and I want to do it in a very functional, readable pattern, right, or readable manner. Okay, so that's kind of the idea of what we want. So can anybody tell me what about these functions, what all these functions have that are very similar to each other? Like what is that property we're looking for? What kind of functions are these? There we go, pure functions. Yep, exactly. Carmen, pure functions, okay? So remember how I said, well, why do you need pure functions in the first place, right? Well, you need that predictability. Well, it's definitely easier to debug, that's for sure, but you need that predictability, and you need to follow some rules where, okay, takes an input, takes an output. And of course, if you think about it, the concept of piping of what I just showed you on the slide is you're kind of, and it doesn't have to be piping, it could be composition. But if you're going from left to right, and you're really just filtering this and putting the data out, and then filtering to another function and putting it out, and then filtering it again, you want this to be very, predictable, right? And in this case, these are all pure functions, and these all abide by whatever rules that I showed you in the beginning. And so here, we're going to first incrementally figure out how we're going to do this. So we're going to do the composition. We're going to do composition with these functions, and we're going to first do it manually. So remember, composition is not like piping. Composition is kind of going from right to left because you're calculating this and then this and then this. So as you can see, the first example I have is called a composition manual, right? It's essentially what we have here, right? F3, F2, F1, put in the argument, you're good, right? And then the F2 takes the F3 as the argument because F3 returns the value, right? And then F1, so on and so forth. So this is kind of like the manual way of doing it. So what if we wanted like a more generalized way of doing it? Well, here is what you would do, right? We would use something like this, right? This is a more generalized way of doing it. You could pass in any function, right? You could pass in, you could pass in double, right? Right? You could pass in whatever it is you want, okay? Pass in -3, divided by 4. I don't know, whatever it is, right? So this is kind of the more general way of doing it. But now we want an even more general way of doing it. So what I did here is, let's see, I console logged here, is I want it so that I can have this for every single function. So this is just compose 3, right? So this is going to, so this is going to basically, this is going to basically only do it for 3 functions, but I want it for n number of functions, okay? And essentially, and I'm pretty sure, I forgot what that utility library was, but essentially is whatever I'm going to show you. But this right here is essentially compose in its kind of raw form, right? So essentially, this is what we were looking for, and you might see this somewhere else. And can somebody remind me, like, what was that library we used in React that had compose? If anybody remembers, in the Telus starter kit or somewhere, I can't recall exactly, but we used compose somewhere. But this is essentially it, okay? This is actually what we want to try to achieve, because now we are going from, again, right to left, right? So we put our initial number in, we increment by 1, we triple it, and then we -2, right? This is kind of the general solution, right? And maybe we ought to run this right now. So let's see if this works. So all these should give me the same number. I don't know what number it should be actually. So let's just do the math real quick. So it's 5, 15, 13. So it's 13, right? So I should get 13 3 times from compose manual, from compose 3, and compose general, okay? So let's just run that real quick. Yeah, okay. Telus isomorphic core. Yeah, that's the one. Anyway, so this general is, hang on. Sometimes it's, I can't really do it. Yeah, there we go. So again, general answer, right? This is the manual answer. This is just, putting it into, 3, and then this is the general one. And of course, we could do, we could double it, right? So hopefully this gives us, the last one gives us 26. Okay, why did I press this? But anyway, 26, and voila, we get 26, right? So again, same concept, right? But now we want to do it for pipe, right? Which is, going from left to right. I think pipe is more intuitive. Compose is a little bit less intuitive because, I think most people can imagine like a conveyor belt in a factory, like a package going through a conveyor belt, going through different like filters, right? Because it's literally from left to right. So again, same kind of concept that we're looking at. The first one is a manual. Give me a second. Let me just comment all this stuff out first. So the first one is a manual way of doing things, right? So, as you can see, left to right, right? X. So we increment the 4, right? And then that 5. So the 5 is being passed into the next function, which is triple, right? Which now it's 15. And then the last one, Z. Z, 15 minus 2. Going to be 13, right? General way, okay, very similar. Okay, very similar, right? Except this is going to work for any 3 functions. Okay, we should see, we should see basically the same result, right? This is exactly the same as this one here, okay? And then the general answer, which is pretty much the same exact thing, which is this, okay? So I'm doing the exact same thing. I'm taking all the functions, and then the second parameter is data. The functions is here, the data is here. Instead of doing a reduce right, so going from the right and then doing it, we're doing a reduce from the left side, right? And then we're accumulating everything together and crunching into one output, right? So this is the pipe. So if we were to, do it backwards, instead of what we have here, which is minus triple increment, it should be increment triple minus, right? And then, I don't know why I put 4 here, but I put the formula right here, right? And then I put 4, which is the initial number. And I'll put it out, and I should be getting the same exact output for all of them. So let's see if I run this. Okay, gonna have to run this. Sometimes that doesn't work. Oh, there we go, 13. And again, we want to double it at the very end, right? We should be expecting 26, right? Because if we can't put it in the front, then it'll be a different number, right? So we'll do that. 26. Right. Yeah. So that is. Let me see. Yes, Carmen.
Hey, so I was just wondering, in terms of like use cases here, like, is it better to use like compose versus pipe, like at any point, since they kind of do the same? Like, when would you use one versus the other?
Okay, I personally just use pipe because I feel like it just makes more sense to me. Because I'm always like, wait, why do I want to go from right to left? I don't know, man. Like, I just use pipe. So, yeah, I don't know. Have you guys used Ramda? Or I haven't actually used it it much, but I don't know if all of them are basically like going from left to right. I actually haven't used it that much. I've used it like once 5 years ago because I had to. But yeah, maybe I'll find reasons to tell you to use compose rather than.
Yeah, because I had to write something, and I was like, well, I understand pipe because it's like easier to read, and it was like see compose. I'm like, but why would I use this one?
I mean, I guess maybe it's literally how it is, right? Like you go, you want something first, and then you want something from right to left first in whatever scenario it is. Maybe that's literally it.
Okay.
Yeah. So anyway, that's it. So I know it's a little bit shorter than I usually take up way too much time, but I would say the next steps for everybody is to really look at things like functors and monads. And I'm not really an expert in those things either. Like I actually have studied them in school. I purposefully kind of left it out because I felt like, it would you guys have enough to be able to go out and read about it yourself. I do understand this a lot better now, after, years of not being in school anymore and really looking at stuff on my own. But, this is something that I wish these are kind of the topics that I wish somebody would have told me, when I was, beginning to look into functional programming and then trying to look into more complicated stuff that, hey, you should probably have a good understanding of closures and currying, and then be able to convert between like a loop to a recursive function, vice versa as well. And then some of these terminologies, especially in JavaScript, even though JavaScript is very, very helpful in terms of having all these nice, kind of properties and features already. Yeah, so this is kind of the thing, the course that I wish somebody would have just kind of given me this type of information. So yeah, so dive into other topics. And what was the other one in that? Let me see, in the picture. What was the other one? Oh yeah, like
I found a good example for compose. Why you'd use compose.
oh yeah, tell us about it.
It's more for React. So when you're composing, say here, I'll post in the chat here. So if you're doing like a to-do list, it reads better to do r.compose container list, r.map list item, and then pass the items, because then you're viewing it technically backwards, but you'd want to build the list item and compose that into the list and then into the container. So it reads better to compose a component. However, pipe makes more sense when you're doing like functional.
Yeah, there we
I
go.
posted it in the chat here if people want to see it.
Yeah, let's see. Yeah, what was the? Hang on, I've seen this in the code base. Hang on, where here, right? Like I always actually wondered, like, why do we use compose here, versus say pipe, you know what I mean?
That's probably because compose comes from Redux, so you'd have to do it their way. Are we actually doing that? Oh, we're taking that from isomorphic core.
Yeah, because
Typically that comes from React Redux, and it's probably the same thing. You'd want to create all of your components and map them together, and at the very final step, you'd want to connect the state. So it makes it easier to read. Otherwise, you'd do pipe, and connect would be the last thing you did. So you'd be composing this in the reverse order.
Yeah, actually, yeah, that makes sense. Yeah. So I'm assuming this wouldn't make, like, if I put this here, it probably not gonna make sense then. I don't know. I'm just kind of.
Well, it wouldn't work, right? Because you
work.
wouldn't have anything. You'd be connecting to current plan, but then you wouldn't be attaching with local until after.
Yeah, that's interesting. Because I personally always thought that it. Like, I don't know. Like I think this you should. It just makes a lot of sense to me that you would have connect at
the only thing is, if you did pipe there, current plan wouldn't be the thing you're piping.
Oh,
it
that's
would be
true, right? Yeah.
What would it be? Connect? Would it be connect? I guess it would.
No,
current plan would be the last thing. It would be the very first thing in your pipe, and then you'd connect. Oh yeah, I don't know how you'd do that with a pipe.
Yeah, again, like we don't know the internals of I haven't looked at the internals of this or know how it works directly with React, but yeah, this is something that yeah. Anyway, I'm not gonna theorize every single little thing, right? But I always wondered. I'm like, shouldn't this be a pipe? Like, I'm just saying it logically. It just makes more sense for this to be a pipe or to go from just left to right. But yeah, I don't know, man. Yeah. Anyway, well, hopefully this wasn't as long as my other presentation, but there's a repo, you can check it out, and yeah, and now that's pretty much it. And this is the last lesson I'm teaching for this year.
Chen, you're free of us now.
Oh man, woo! What if I told you I kind of regretted signing up for all those lessons? No. It's kind of hard to juggle all those things while working on a bunch of stuff. Yeah. Anyway, yes, you guys made it worth it because I learned a lot too. Refreshing some old content or like just things that I thought I understood, but then I'm like, oh, I understood a lot better. And so, how'd you guys like when I was doing those diagrams? Did you like how I kind of use those diagrams to show the stack and then the objects part? Again, I don't know how you guys learned it, but for me, it was just so, especially the objects. Like I really think you have to draw it out. Like in the very beginning, at least, you have to draw it out and understand. Like, okay, this thing goes here, this thing points here. And by the way, did you guys know about object.create, like what it actually did? Like without drawing the diagram, I'm just wondering. Anyone or was it?
No, did not
Cody?
know. That was really handy.
Yeah, because I didn't. I'm like, wait, what does this inheritance thing do? But it's not. It's just you link it, and object.create creates an empty object, and it links to the prototype of that other object, right? And that's how it's able to access the method. Yeah. Anyway, I have a lot of other stuff to do, so that's it. I will see you guys. I don't know whenever, and yeah, you can access all the stuff in the GitHub repo. Okay. All right. And thanks for the help, Cody. I hope you're gonna stop recording now, right?
Yeah, I just turned it off.
Okay. Nice.
Is
All right.
it-
Okay.
Oh,
Thanks,
it's not
everyone.
stopping.
Okay,
Oh, here we go.
bye.